Hi guys, welcome to another episode of MrLopezClasses.com. This is the episode number, this is chapter 3, episode number 1. This video is related with the switches, relays, and solenoids for electronic components. We talk about the switches, relays, and solenoid in our electrical book for electrical circuits, but that is exactly the same. Oh yeah, of course. You remember the relays, the 101 relay? We are going to use relays exactly like this, but electronic. This relay is exactly like the relay that you have on the screen right now. The only difference between this relay, the electrical relay, with the electronic relay that you have on the screen is the terminals. If you check on the screen, the legs of the terminals are ready to be inserted in the circuit board, in the perforated circuit board like this. You inserted the relay, and after that you soldering the relays. Okay, this relay and this relay is basically the same. It's the procedure to check those relays is exactly electronic relays or electrical relay is basically the same. For that reason, we are going to use the same video that we use in our electrical class in order to do the diagnosis on relays. What is the meaning of an electrical circuit and an electronic circuit? The electrical circuit is a path only to flow electrons from one point to other point. It's a path, an electrical part with wires in order to move electrons from this point through this point. This is an electrical circuit. And the flow of the electrons depends on yours if you open or close the breaker. This is the electrical circuit. The electronic circuit is more intelligent. You can program the electronic circuit, and the electronic circuit make decisions. That's the main difference between electrical circuits and electronic circuits. Both of them move electrons from one point to other one. However, the electronic circuit is intelligent. The electronic circuit makes decisions. The electronic circuit stop and start depending on the programmation. The electrical circuit now, on, off, and the current pass or no pass. That's the main difference. The main difference is the electronic circuit make decisions. The electrical circuits, no. Okay. You remember when we did the wiring, the harness for any type of engine, diesel or gasoline? You remember the analog control box on an analog engine, gas or diesel? You remember the video related with the harness, the construction of the harness from the control box into the sensors per any type of engine? Okay, this is the control box of an analog engine, gas or diesel. This is preheat, start, stop. Those are the fuses, and those are the relays. This is an electrical control box for an analog harness. Oh, if the engine is the new generation, the engine is digital. The engine use, instead of an analog control box with electrical devices, the engine use an electronic control box. This control box is exactly like this. If you have here a start, stop, and run relay, you have a start, stop, and run relay. Exactly the same. And you have the input of the power coming here, and the output of the power coming in on the harness for analog. In digital, you have one socket for input power, input signals, and you have another socket for output signals. And the circuit board creates the path per each circuit. You have one path here for fuel, and you have other one for start, and you have other one for stop. This is an digital control box, and this is an analog control box. What is more accurate? Probably this one. But what is easy to repair? The analog. Because you can remove easily the relay. You remove the relay here right now, and you check if the relay is good, 85, 86, 30, 87, and the relay is bad. You replace the relay for a new one, you put the new one, and you start the engine. What happened with the digital circuit board? If you check, in front of each relay, you have an LED. Okay. Normally, if you check the manual of this engine, they say that if the engine is running, those LEDs should be solid, on. If one relay is blinking, it's because probably the relay is in short. If one LED is off, it's because that circuit is open. In that case, what is the procedure? If this relay is damaged, you need to go in the back, and with a soldering equipment, you need to remove the relay and replace the relay for a new one. It's a little more difficult. It's not complicated, but it's more easy work with analog in comparison than digital. Digital and analog. Yes, we are going to use the same procedure to solve problems with the analog circuits. It's the same procedure that with digital. In digital circuits, you manipulate milliamps, microamps, milliohms, microamps. In analog circuits, you manipulate amps, kiloamps, kiloohms, high voltage, low voltage, high amps, low amps, high resistance, low resistance. For that reason, this is electronics, microcurrents, micro voltage, microamps. Small currents in electronic circuits, higher currents in electrical circuits. Okay, right now we are going to check the video in order to refresh our concept of how to diagnose a relay, and how to diagnose a solenoid, how to diagnose the crank relay, the Bosch 101 relay, exactly the same like the other ones. And in the last part of the video, we are going to check time delays relays. And we are going to study the procedure to install and diagnose relays and solenoids. This is a switch or breaker. That's the input, the output, or input-output. And this particular equipment, this particular switch, this particular breaker is activated manually with your hand. When you open or close the contacts open or close with your hand. When the contacts are open, the switch is off. When the contacts are closed, the switch is on. This is a normally open switch, manually activated. And this is a relay. This is a typical crank relay. This is exactly the same like this relay, the crank relay. Position A, position B, normally open. And this close when a remote signal enter here from other place. In your boat, for example, from the flybridge or from the pilot helm. When you activate the ignition switch, you send the current and a small signal, DC, positive and negative, or positive and negative, doesn't matter, because this is a coil. When the signal enters, immediately the gap between A and B close. What happened internally in the relay? Normally, the terminal A, the bus of the terminal A is a copper metal, and the terminal B, they are separated. But in between both of them, there is a piece of ferrous alloy, steel or alloy, or ferrous alloy. That piece of metal in between this terminal and this terminal is surrounded by a coil. The beginning and the end of the coil are those terminals. When you powered that coil, the iron becomes a magnet and goes down and close the gap between A and B. When you remove the power on the signal, the magnetic properties on the iron disappear and the iron separate and A and B is separated. This is basically the schematic. This is position A, position B, and this is copper and copper. Position A, position B, copper and copper, and internally a piece of ferrous alloy, iron, is located in between A and B, but with those springs, that metal is separated. And this is the coil surrounding the metal, the ferrous alloy metal. Those are the terminals, the input and output for the coil. When the signal enters here in the coil produces electromagnetic interference and the metal becomes a magnet. When the metal becomes a magnet, the metal goes down and close the gap between A and B, and the big current pass through the other side. I have a good example in this board that I prepared for use. I have the star relay. That's the input. This is the output. In this moment is open. In this moment, if I check with the probe, I have power here. I have power here. The light is on, but I don't have power here. When I send the signal positive and negative, that's the positive. Right now I send the signal here. I have power on the signal, and of course I have power in the output, and of course the light is on. When I turn off the switch, I don't have power in the output, I don't have power on the signal, and the light is off. It's simple. Do the diagnosis in a relay. In this moment, no input signal. I have power here, but the contact is normally open. I don't have power in the output because I don't have signal. When I bring the signal, immediately I have power in the output and the light is on. This is a normally open switch with a remote activation. This is the typical crank relay. Other relay that we are going to use every day is this relay, the Bosch relay or 101 relay. This is a relay that we use in millions of applications. If you check the dashboard in your car, behind of the dashboard, you found that 100 of those relays for different applications. One relay for start the engine, other relay to stop the engine, other relay to control the operation of the engine, other relay to activate the fuel pump, other relay to activate the stereo, the radio. There are hundreds of relays installed in your boat or in your car. How this relay works? This relay have this is the coil. The nomenclature said for the coil, the number for those terminals is 85 and 86. 85 and 86 for the coil. And this is the signal, the input signal that I wanted, that signal. And this one on top should be the output signal that I wanted to send. In between this terminal and this terminal on top, in between this terminal and this terminal, the connection is normally open. When I don't have power in between 85 and 86, those terminals are open. When I power it, those terminals close and the light is on. The advantage of this relay is that you can find it relays like this with the connection between this and this normally open. And connection between this and the middle one, normally closed. What is the meaning of that? When I don't have power on the coil, the connection between 30 and 87, between this and this, is normally closed and the light is on. When I powered the coil, this connection open and the light will be off. In other words, I can use this relay for two purposes. In between this and this, the connection is normally open when the power is off. When I power it, the connection between 30 and 87 closed and the light will be on. In the middle, the connection between 30 and 87 in the middle is normally closed. If you check continuity between this and this, you have continuity beep, between this and this. The light is on if the power is off. When I power it, immediately that connection open and the light off. Okay guys, now we are going to verify in the board that I prepared for yours how the bus relay works properly. Okay, in this board, the input signal, the signal in the terminal 30, the input signal is coming from this positive common bus bar. And we have two signals, one in the middle. The connection in between 30 and 87A in the middle is normally closed. And the connection in between 30 and 87 outside is normally open. Okay, in this moment, the switch, this is the switch for the power in the coil, this is the negative, and this is the positive. Okay, in this moment, the switch is off. No power on the coil. Okay, we are going to check what happened in the external. When I don't have power in the coil, that connection is normally open. Okay, in this moment I don't have power. That connection, the external, is the red one. The middle one is the green. Okay, in the external, right now I don't have power in the coil. The connection is off. When I power it, the coil, immediately the connection in between 30 and 87 is on and the light is on. Okay, now we are going to check the middle one. No power in the coil. The connection is on. The light is on. Now I power it. The connection is disconnected and no power here in between 30 and 87A. Off. This is the procedure. It's simple to check that relay, the bus relay. The bus relay can be used for two purposes. To activate equipments, you can use 30 and 87, the external. To stop engines, you can use the connection in between 30 and the middle one. The middle one is 87A. Now we are going to continue with the solenoids. The solenoid is basically a relay, but in the moment that the connection between A and B is closed because the signal entered here, when the connection closed, when the gap in between A and B closed, additionally an external movement is produced. When the gap closed, an external piece of metal goes out. Like this. The relay is basically, the solenoid is basically a relay that the external metal goes down. When the coil is activated, the metal goes down and the plunger goes down and close, open and close. When the gap between A and B close because the signal on the coil enter, the metal goes out. Solenoids are used for millions of applications. Solenoid is the first step to convert electrical signal into mechanical movement. Solenoids is the first step to create robots because convert electrical signal into mechanical movement. In other words, a solenoid is a relay, it's exactly the same, position A, position B, and this is the signal, and this is the mechanical movement. The star motor like this, position A, position B, and this is the signal coming from the ignition switch in the start position. I have a good example of the star solenoid and the star relay working at the same time. I show to you that example. Okay guys, in this particular example, I have a board that I prepared for yours in order to explain properly the crank relay and the star solenoid. That solenoid is part of the star motor. When the solenoid is activated, the gear, the small gear, the bendix engage with the flywheel of the engine and the engine crank. This is the star motor, this is the solenoid of the star motor, and this is the star relay. The ignition switch, remember the ignition switch have one input, is the power coming from the battery, from the positive bus bar, and two outputs. One output, ignition position, and other output, start position. In ignition position, when you select ignition in your car, you remember the first position, ignition, is a permanent position, In that position, you hear that some equipments are activated. The lights on the board, the radio, the fuel pump, you hear the fuel pump, and you hear other equipments be activated. Those equipments are activated because the ignition switch sends the signal and some relays close or open, depending if the relay is normally open or normally closed, depending if the relay is used in the 87A output or in the 87 output. Okay, in this particular case, the ignition switch have power on the battery, but no power in the input, but no power in ignition and no power in start. Okay, when this is the power coming in from the battery, and this is the power on the ignition position, the first position, ignition. Okay, right now I have power here. When the power enters in ignition, immediately I have power here on the signal. This is the input power from the battery, and this is the output power. The output power right now is on because the relay is activated. That's the signal. Okay, right now when the relay is activated, I have power here at the input of the solenoid. But I don't have power in the output because I don't have signal here. What is the color code for the signal on the solenoid of the start motor? Yellow, red. What is the color for the signal on the start relay? Is purple. The purple signal is coming from ignition, from this position. And the yellow-red signal is coming from start position. In this moment, start is off. I don't have signal here. When I activate start, the light is on. I don't have power in the second. When I activate signal, the power passes to the second one because the signal enter here and the motor is activated. This is a typical example where you combine a relay, the crank relay, with the crank solenoid or start solenoid. The solenoid is located on the start motor, and the relay is part of the system. What is the function of the relay in a typical marine installation? For what reason you need the relay? You need the relay to avoid that you have power constantly in this point. Remember, what happened in a typical boat for the location of the engines between the starboard engine and the port engine? Normally, in a typical boat, you have a small space in between the starboard engine and the port engine. You practically have a space to pass one person in between both engines. And where is located the start motor in each engine? In between the transmission and the engine, in the bottom of the engine. If you are working in other equipment, air conditioning equipment, or installing a bilge pumps, and you have tools in your pocket like this, and you don't have relays like this, you have constant power in this terminal. If you are working and you approximate the tool to this point, you can produce a short, you can produce a spark, and you can produce an explosion. In other words, this equipment, the relay, is installed in order to avoid constant power in this terminal. You only have power here when the relay is activated. If the relay is off, you don't have power here. And it's safe to work in other equipment. In marine applications, it's mandatory the installation of the crank relay. In my car, I don't use crank relay. This cable passes directly to the start motor. Yes, because in your car, you don't have the inconvenience of the space in the engine room. This is the installation of the crank relay and the start solenoid. You remember when I explained to you that when you activate ignition, with the ignition cable, the purple cable, you activate, this relay, but also you activate an ignition bus bar. From the ignition bus bar, you activate gauge, oil pressure gauge, temperature sensor, tachometer, hour meter, 100 of equipments, and also you send signals for the harness of the motor. This is the typical control box. This is the typical control box of a diesel or gasoline generator or diesel or gasoline engine in a typical boat. This is the start, preheat, and stop. The start switch, preheat switch, and stop switch. Each switch, start switch, preheat switch, or stop switch is connected with one relay. Start relay, run relay, and stop relay. Start relay, run relay, and stop relay. Each switch is switch. This is a normally open switch. When you press the switch, you close the contact and you activate the relay, and the relay sends the signal. This is the typical installation in a boat for generators or engines. Can I replace those switches, start, run, and stop, for this type of switch with 3 positions: battery, ignition, and start? The typical ignition switch, yes. The battery is the start, the ignition is the run, and this is the start. It's exactly the same. You can replace one of these, those switches, normally open switches, for the typical ignition switch. In other episode, I am going to explain the procedure to do the wiring for a complete harness for a diesel or gasoline engine. We are going to do the wiring step by step for the engine, diesel or gasoline. And we are going to do the installation of the control box in any type of engine, gas or diesel. Okay, this is the explanation about relays and solenoids. The solenoids can be used in other type of application like this. This is a solenoid. When the solenoid is powered, positive and negative, immediately the plunger closes the valve. This is a solenoid valve to control the movement of the fluid. What type of fluid? Water, gasoline, diesel, gas, alcohol, any type of fluid. The fluid can be controlled. The fluid enter here and continue over there. You see the shape of that valve. Okay, when the plunger is off, the valve is open and the fluid pass. When you activate the coil, the window close and the fluid no pass. This is a typical solenoid valve or shut-off valve. Where you found this type of valve in a boat? The shut-off valve for fuels in the output of the fuel tanks, or the shut-off valve at the entrance of the fuel injection pump to avoid that the fuel enter in the fuel injection pump and the engine stop, or the idle the idle solenoid on the carburetors to control the idle and to control that the engine start and stop. There are other applications in hydraulic system. In air conditioning system, we use solenoid valves. In an air conditioning system, the solenoid valve used to reverse the cycle from heating to cooling or cooling to heating. It's a solenoid valve, 3-way valves that control the flow of the refrigerant to the evaporator or to the compressor, heating or cooling. There are other applications that we are going to study in our class of auxiliary systems or in hydraulic systems, and also in our class of air conditioning. We are going to study other type of solenoids. Solenoids is the first element used to produce robots, because it's the element that converts electrical signal into mechanical movement. Hey guys, time delay relays. The time delay relay is a regular relay with a time delay system incorporated internally. What is the function of the time delay? The time relay is a relay that can control the output signal. You can program the output signal to start each 2 hours during 20 seconds and stop again. This is perfect, for example, for cameras, circuit of security cameras. You need to start those cameras after 6 p.m. during 2 hours, stop 30 minutes, and start each 2 hours. This you can program that situation with a time delay relay. Other common situation is the air conditioning equipment. You can program your air conditioning equipment to start the air conditioning equipment at some time during some interval of time. This is easy to program with time delays relays, like the relay that you have on the screen right now. The relay that you have on the screen right now have 2 buttons. The first button will be used to calibrate the time interval, and the second button is used to determine the time of each signal. You can adjust the time interval and the time of each signal with each button. Those are time delay relays. You have in your boat a lot of time delay relays to program air conditioning equipments, hydraulic systems, to program start the generators, start the water makers, time delay relays. A lot of time delay relays we are going to use. In our class of auxiliary systems, I am going to explain in each equipment where is located the time delay relay and what is the diagnosis. The diagnosis is exactly the same like the bus relay. Other common relay that you found is the multiple relay. Okay, let me explain what is the meaning of multiple relay. This one is the regular bus relay. This one, the input is the 30. The output, there are 2 outputs. One output in 87, normally open, between 30 and 87, normally open connection. In between 30 and 87A, normally closed connection, and this is the output. This is the typical bus relay. What happened in this relay? I only administrate one signal. The input signal is here, and you have 2 options. One option for normally open or other option for normally closed. But what happens if I have a relay that I can introduce 3 different signals in order to send 3 different signals? For example, like this. Look, this is 85 and 86. This is the coil. This is the common, 30, 30, and 30. The same like this, 30. And this is 87A, 87A, 87A for this column, and 87, 87, 87. In other words, I can send through this signal, I can put here 6 volts DC. And I am going to use the output here, 6 volts DC. And I wanted to send through this one in the normally closed position 20 volts AC. And here 20 volts AC. And I wanted to send in this one ground. And I send the ground here. In other words, when I bring the power 85 and 86 in those terminals, I send 3 different signals. This is a multiple function relay. Each column is independent. This column is independent of this, and this one independent of the other one, and this one independent of the other one. In other words, if I have this relay and I only want to use one column, I can use the relay. This is 3 relays of this integrated in one. It's this one. Look at the relay. 85, 86. This is 30, 30, 30, the middle ones. 87A and 87. You have on the screen right now that relay, 85 and 86. On the screen right now. On the screen you have the input 30s. On the screen you have 87A and 87. This is a multiple relay. It's widely used in millions of applications. This relay is multiple columns and additionally is time delay. If you check on the screen, you adjust with the screwdriver the interval of time here. This is a time delay relay, multiple columns.